L'Hopital rule. So L'Hopital rule only applies to indeterminate form. Of the following are indeterminate form: 0 over 0, infinity over infinity, infinity minus infinity, 0 times infinity, and then there are a few more, but that's what we have for now. So when we have the limit in one of those forms, we can use the Hopital rule, meaning we can take the derivative of the limit equal to the limit when we take the derivative at the top divided by the derivative at the bottom. That is not the quotient rule. We just take the derivative at the top divided by the derivative at the bottom. Alright, so first thing, by the way, I think this is go to -5 and not 5. So first thing, always put in the number into x. And see, if it is a number that is defined, then that will be the limit. We make them equal. Alright, so 25 minus 25, 0, 0 over 0. So this is indeterminate. Because it is indeterminate, we can use the Hopital rule. So we take the derivative of the top, x squared minus 25, the derivative is 2x. The derivative at the bottom, x plus 5 is 1. So this is just a limit as x go to -5, 2x. And then we put in the numbers, see what happened. And that is equal to -10, and that is a number that is defined, so we make the limit equal to that. So simple enough. It have to be in indeterminate form to use the Hopital rule. Right, now let's put in 0 cosine of 7 times 0 minus 1 over 0 square. Cosine of 0 is 1 minus 1 over 0, which gives us 0 over 0. Once again, it is indeterminate. So that means we can use the Hopital rule. Just take the derivative of the top divided by the derivative at the bottom, which is 2x. And the derivative of cosine of 7x, I will use the chain rule. The derivative of cosine is negative sine. And then the derivative of the parentheses. Derivative of 1 is 0, so that's we don't have anything there. So that gives us derivative of 7x is 7, so at -7 sine of 7x over 2x. Alright, now put in 0 again, see what happened. -7 sine of 7 times 0 over 2 times 0. Sine of 0 is 0. 0 times -7, so we have 0 over 0. Once again, it is indeterminate. As long as it is indeterminate, we can use the Hopital rule. check the derivative of the top, derivative of the bottom, which is just 2. Right, and again I will use the chain rule. Derivative of sine is cosine, and then derivative of the parentheses. Right, derivative of 7, x is 7 times negative 7, negative 49 cosine of 7x over 2. Right, and I put in 0, see what happened. Negative 49 cosine of 7 times 0 over 2. Cosine of 0 is 1, so we have negative 49 over 2. Now that is a defined number, so we'll make it equal to. Right, so that's what we have for the limit. Next, we have the limit when x goes to infinity. Well, of course we can put infinity in it, but we just get infinity over infinity. Rather do that, I don't recommend using L'Hopital rule here, because we have a better rule for that. And the rule says as x goes to infinity or negative infinity, a polynomial, only the highest power term matter. Alright, so in that case, we'll just take the highest power term. And cancel out 1x. Right. Then we can substitute in. Let's see what happened. Right, so we have finite divided by infinity, a very small amount divided by something go to infinity. So this one goes to 0. And so that's what the limit is equal to. It's kind of awkward to write equal to, so we just say it. So limit (5x plus 8), 7x squared plus 6x minus 5 equal to 0. Yeah, finite divided by infinity is equal to 0. So let me write out those rules. Alright, when you have 0 divided by something that is not, it's going to be 0. Something that is not 0 divided by 0 is undefined, and that could be plus or minus infinity. And 0 over 0 is indeterminate. Now, infinity divided by something that is not. Something not infinity means infinite. Now, if we flipped, finite divided by infinity is equal to 0, and infinity over infinity is indeterminate. Right. So those are the rules that we have. Now we have number 20 here. Right. I just put in numbers and see what happened. We have infinity times sine of 4 over infinity. Now focus on the sine of 4. Finite divided by infinity. So that is the same as sine of 0. And sine of 0 is 0. So we have infinity times 0, which is also indeterminate. Right. Now, so that means we use the L'Hopital rule. The only problem here is we don't have a quotient, right? In order to use the L'Hopital rule, we need to take the derivative of the top and derivative of the bottom, which we don't have here. So what we have instead, see, I don't use the L'Hopital rule yet, so I will not write the red LH on the top of the equal sign, right? I just want to rewrite this. Notice the x here, if we move to the bottom, it becomes x to negative 1, right? Then we have sine of 4 over x on the top. And also, if we want to, we can also say sine of 4 times x to negative 1. Right. We don't have a quotient now, which we can use the L'Hopital rule. Right. We use the chain rule here. Sine of something is cosine, and then derivative of that. Doesn't matter what inside the parentheses. And we take the derivative of the bottom, which is negative x to negative 2, right? Right. So we have cosine of 4x to negative 1, and the derivative of this is negative 4x to negative 2. Notice that we can cancel out the x to negative 2 and x to negative 2. Negative 4 divided by negative 1 is 4. So that gives us right? Negative 4 divided by negative 1 is a 4. Now I will rewrite the x to negative 1 if we move to the bottom. Right, much better. Now let's just put the numbers in. Infinity into x. Where's the cosine? Our 4 divided by infinity, finite divided by infinity, so that one goes to 0, and cosine of 0 is 1. So we have 4 times cosine of 0, 4 times 1 is 4. It is a defined number, so we make it equal to. So the limit equal to 4. Right. So once again, only use the L'Hopital rule if it is in indeterminate forms. And we need a quotient for that. But it's not quotient rule. It is derivative of the top divided by derivative of the bottom. Right. Now we go to indefinite integral, or find all the antiderivatives of this. Let's just put the formula for antiderivative. Right there. So those are the rules for the antiderivative, or the integral, indefinite integral. Right. Now the first one is just power rule. So in order to use power rule, we just write everything as power. So I recommend, so we haven't done anything yet. Recommend we write this as 1/7 t dt. Now we will apply the power rule. What is that? For every power. So t square and t. Increase the power by 1, t square, increase 2 plus 1 is 3, divided by the same thing. There's a 4 in front of that. And then integral of t be t square over 2. And then plus 1/7 times. Right. And remember, the integral, indefinite integral, will be the set of all antiderivative. So it's going to be plus a constant c. Right. So just power rule for each term. Now let's just rewrite this. We divide by 3 is multiplied by reciprocal. Can make 3/1. So multiply 1/3. T cubed 1/7. The 2 at the bottom, divide by 2, multiply by 1/2. So that gives us 4/3 t cubed plus 1/14 t square plus c. Right? So it's power rule to make sure we have powers, of course. Likewise, in this case, we have to rewrite, and also the notation though. The integral sign and the dt, dx, or whatever it is, go together. It's just like the quotation mark. When you remove one of them, you remove both of them. When we apply the rules. Right, square root is 1/2. And again 1/2. Right, I will rewrite this. Divide by 2, so multiply by 1/2. Plus 4. I move this to the top, becomes negative 1/2. Now we have powers. We can use power rule. Sorry, color code. The rules for those powers. We have 1/2. Increase the power by 1. 1/2 increased by 1 is 3/2. Increase the power by 1. Negative 1/2 plus 1 is 1/2. Divide by the same thing. Plus c. Right. Now we have 1/2. Divide by 3/2 is multiply reciprocal. 2/3. Yeah, flip it. 1/2, so that 2. So that gives us 1/3 y to the 3/2 plus 8 y to the 1/2 plus c. Yeah, of course you can write that as square root and radical form for that, but that's good enough. So that's power rule. Next, integral of cosine. So integral of cosine is positive sign, and we just have a negative 7 in front of it, plus a constant c. So just that. Next we find the integral of this one. So we can find the derivative, the integral of sine and cosine. Of course all the rules are over there. Okay, yeah, that's fine. Right. But remember, unlike derivative, there's no quotient rule, no power rule. So in that case, we just try to simplify this first. So we try to simplify it. We do not apply any rules. So that's why the integral sign is still there. Right, cosine is, cotangent is cosine over sine, and cosecant is 1 over sine. Now multiply it out. Sine times sine cancel out. Yeah, just multiply it out. And sine right, that cancel. Just have cosine plus 1. And derivative of cosine is sine. And derivative of a constant is a constant times the variable. So 1 times theta plus c. Yeah, so pretty much that. Right, next, solve the initial value problem. So initial value problem is just like what we've been doing, find the integral. However, initial value problem, we have the initial condition, and this condition allows us to find a particular values for c, so we have a particular solution. Right, anyway, derivative is equal to that. So to get back to the function, we integrate to undo the derivative. Right, now power rule apply for this power. Increase the power by 1 and then divide by the same thing. Negative 3/4 plus 1 is 1/4. Divide by the same thing. There's a 2 in front of it. And then plus a constant c. Right. Now divide by 1/4 at the bottom is multiply reciprocal. Right. So that gives us 8x to the 1/4 plus c. Next we have the initial condition. Y of 1 is equal to 9. Meaning if we put 1 in for x, we have 9. Now we put 1 in for x. And we make that equal to 9. Right, 1 raised to any powers is the 1. So it's 8 plus c is equal to 9. So c is 9 minus 1. Is 9 minus 8 is 1. So c is equal to 1. Substitute into this c, thus y equal to 8x to the 1/4 plus c, which is 1. So that is the solution to this initial value problem. So we just integrate, undo the derivative, and we use the condition to solve for C. And when we substitute back for C, we have the solution. Right? Now, let's look at this problem. Suppose the velocity of the body moving, so in that case, find the body displacement over a time interval from t equal to 3 to 7, given that s is equal to 2 when t is equal to 0. Right? So the displacement from 3 to 7. Right, so pretty much let's just find the function, see what happened. Right? So let's try the problem again. We have ds over dt equal 9.8. The 9.8 okay. It's coincident that negative 9.8 meter per second square is acceleration due to gravity. This is not that 9.8, so different coincidence. This is not acceleration due to gravity. Right. Now, integrate to get back to the function. Let's just say the s-axis. Right, so integrate. At the typical the negative 9.8, the acceleration due to gravity usually negative because it's pointing down. And by the way, they said along the x-axis, not the x or y-axis, so different. Right, so just integrate. Power rule, we have a power, so increase the power of 1 to 2, divide by the same thing. We have 9 times. Then we have a constant, integral of a constant. Just take that constant, multiply by t. And there's a plus c, 9.8, sorry. So 9.8 divided by 2, 4.9. Right, next we have the condition that said when x equal to 2, t equal to 0. I should say when t equal to 0, s equal to 2. So if from here we make t equal to 0, that equal to 2. Right, 0, 0, so c is equal to 2. So we can substitute this back to c. So we do have the function s equal to 4.9 t squared minus 5t plus 2. Right? The displacement is different from t equal to 3 to t equal to 7. So we just say s of 7 minus s of 3. Right? So let this 7 store into x or t, 4.9 x squared minus 5 s 5t, sorry, plus 2. We have that, and now we put 3 in for x. Do the same thing, and so we have at t equal to 7 we have this much, and at t equal to 3 we have this much. Subtract them, we have 176. So the displacement from t equal to 3 to t equal to 7. That's what we have. Right, next, approximate the area under the curve above the x-axis using n rectangles. Right. So we need the calculator on this one. Right. So let's just do some sketch. So first we have from x equal to 1 to x equal to 5 using 4 rectangles, and then we use the right endpoint. Right. So first, delta x, the width is equal to, say width is b minus a over n. 5 minus 4, 1 divided by 4, 4 over 4 is 1. Right. So let's do the sketch. Right. 1, 2, 3, 4, 5. The function, let's say put 1 in here, we have 1, so kind of like that. Right, and we use the right endpoint. So for every, by the way, the width is 1, so we have 1, 2, 3, 4, so 4 in sub-interval, and we use the right endpoint. So from 1 to 2, we choose the right point of 2. From 2 to 3, choose the right point, 3. From 3 to 4, choose the right point, that gives us 4, and then 5. Right, so 5 rectangles, and so we use this point, the right end point. Right, so for each rectangle is the width times the height based on those points. Factor out the delta x, which is 1 by the way, and we have f of 2, f of 3, f of 4, f of 5. Right, and we enter the function 3x squared minus 2, right, and evaluate at this point. So y1, or if you write that variable, y variable function y1, either way, we have y1, second parentheses 2, 3, 4, 5, close. So we evaluate the function at 2, 3, 4, and 5. Right. Now we're going to add all of this number. So second stat, go to math, option number 5, and we just add everything. That, so we have delta x is 1. All of this add up is 154. So that's what we have. So approximately, using 4 rectangles from 1 to 5 and using the right endpoint, the area under the curve is approximately equal to 154. Right, next we have this function, also 1 to 5, 4 rectangles. I'll try something else, make it more interesting. Let's say 1 to 7. I still 4 points using the left endpoints. Alright, first we find the width, which is delta x, b minus 8 over n, b minus 8 over n. So 6 divided by 4 is 1.5. right? So we just draw a line. Otherwise, we don't have to. We don't have to even draw the graph. We just need to draw a line from 1 to 7 and choose pretty much choose 4 points, right? So 1 to 7. And then divide into 4 rectangles and using the left endpoint, right? So 1 to 7, divide this into 4 rectangle, 4 sub-interval, right? So 1.5 is the width, so 1 plus 1.5 is 2.5, plus 1.5 is 4, plus 1.5 is 5.5. And then this time, for each sub-interval, we use the left endpoint. So for the first interval, we use 1. For the second interval, 2.5 to 4, we choose 2.5. For next interval, from 4 to 5.5, choose 4. And from 5.5 to 7, choose the left point, 5.5. Of that, we have the width times the height. The height is on the left endpoint. Evaluate at those left endpoint. I can factor out the delta x. F of 1. Yeah, I just change the problem so it will be different than what we have on the previous problem. Alright, now just enter the function, which is 1 over x squared. To be sure that it's actually 1 over x squared, just say 1 divided by x squared. Right. Evaluate the function at these values. So alpha trace y1. Evaluate at this 1, 2.5, 4, 4, and 5.5. Close the curly bracket, close the parentheses. We have that. And then add all of this up, second stat. Go to math, option number 5, and we add all of them up. So that is that. Delta x, the width, 1.5, and multiply by that. Times 1.5. And we have 1.88326, so let's say 1.883. Right. So that is estimate approximate the area under the curve using the left endpoint of each subinterval, and we're using 4 rectangles. So that's what we have. Now, this one we just use geometry to evaluate. Right, x minus 1, so that is the linear function. Just make a little table. When x equal to 2, 2 minus 1 is 1. When x equal to 6, 6 minus 1 is 5. So we have when x equal to 2, it is 1. And when x equal to 5 is equal to 6. Sorry, when x equal to 6 is equal to 5. So this is the function. And we evaluate from 2 to 4, 2 to 6. Yeah, and the area under the curve. That will give us the integral, the definite integral of x minus 1 from 2 to 6. So in that case, we just find the area using rectangles and triangle. So if we make this there, so we have a rectangle here, 4 by 1, so that is 4. And then this is a triangle, so 1/2 base times height. The base is 4, and the height from 1 to 5, that's also 4. So that is 8. So that is 8 plus 4, so this is 12. Yeah, just the area under the curve. Of course, if we want to test them to see if it works, hit math, option number 9. We go from 2 to 6. X minus 1. Dx. Yeah. Simple enough. Right? Now, absolute value of x is a v. Right, and we go from -1 to 5. Right, so we have two areas under the curve. Both of them are triangle. So for this triangle, 1/2 base times 1/2. The base is 1, the height is 1. So that's 1/2 is the area of that. Now this one, the area is 1/2 base times height, which is 25 over 2. So put them together from -1 to 5. Absolute value of x dx. This area, both of them above the x-axis, so we just want to add them. If it is below the x-axis, we have to subtract. Below the x-axis, the area is still positive, but the net area is negative. So anyway, 26 over 2, that's 13. Right, next, the figure shows the area of the region. So that region is 9, 5, and 4. Evaluate the integral that go from A to C. Right, so the definite, I forgot the x there. The definite integral is the net area will be the area above minus the area below. So that's all we have. Right, next, suppose that f and g are continuous and that integral from 3 to 7 is -2, and from 3 to 7 of g of x is 9. What is that? So the properties of the integral is just like derivative, just like limit. summation, we can just split them. And then take the constant outside. Right, now the integral of f of x from 3 to 7 is negative 2. So 4 times negative 2. And then for g of x from 3 to 7 is 9. So minus a plus 9 is positive 1. Right, so integrals, just like derivative, just like limit, just like summation, we can split and take the constant outside. Right, next we have the integral from negative 1 to 2 of h of x is 2, from 2 to 9 is negative 8. So find the integral from negative 1 to 9. So let's do that first. Negative 1 to 9 ht dt. Right, so that's what we need, and that's not what is given. What we can do though, the limit from negative 1 to 9, we can go from negative 1 to something, and then from that something to 9. It is, remember, the integral, we always from the bottom to the top. From negative 1, let's say we have the 2, so let's try that. By the way, x or t, it doesn't matter, as long as it's consistent with x and x, x and x, t and t, same thing. Right, and then since we stop at 2, we pick it up from 2 and go to 9. H of t dt. Right, from negative 1 to 2, the integral is going to be 2, and from 2 to 9, the integral is negative 8. So that gives us negative 6. Right, next we also need to find the integral from 9 to negative 1. Well, compare that one and this one. We're just going to flip the limit. If we flip the limit, if we flip this, the integral becomes opposite to it. And the integral from negative 1 to 9 is negative 6. So negative 6 is positive 6. Right. So definite integral is the area, the net area under the curve. So that could be positive, could be negative, depends on the being above or below the x-axis. Now on this problem, they only ask for the area, not net area. So we just have to have this area plus this area. By the way, this problem I only test using the derivative. I mean, understand the problem, not actually how to calculate them. So this is the area from 0 to 2. And this is above the x-axis, so we just say from 0 to 2. The function is 4 minus x squared. Right, it is above the x-axis, so when we do this, it's guaranteed to be positive. And on this problem, like I said, only test the concept and not testing how to do the integral. So that's why we can just use the calculator. From 0 to 2, 4 minus x squared dx. Right, can we change the fraction? Yep, 16 over 3. So that is the area. Now if we do this one, integral from 2 to 3, right, to 3, 4 minus x squared, right, convert to fraction. It is negative. It's not a surprise because this is below the x-axis, so definite integral should be negative. However, this time we want the area. Area cannot be negative, that's why we will have to throw in the negative for anything that is below the x-axis. So guarantee to have the area. By the way, this problem asks for the area, not the net area. So that's why we have this. And then plus them. That will be 23 over 3. So total area right. Next we have this. Right, once again, this is above the x-axis and that one is below. Right, look like we go from 9 to 16. So 9 to 16 square root of x minus 3 dx. Square root of x minus 3 dx. Right, can we change the fraction? Yep, 11 over 3. Right, and now this area. Once again, we talk about area. So this is below the x-axis. You just go ahead and put a negative to turn the result to positive. Go from 0 to 9. Square root of x minus 3. Right, negative. Zero to 9 square root of x minus 3. So that should be negative. Right, a little bit off, but that's why the calculator have error as well. So it's just negative 8.9999999. Actually, should be that. So it's just negative 9. Don't worry, on the test the number should be nice and even. By the way, it's negative 9. So turn to positive 9. So we're just going to add them. I change the fraction. 38 over 3. So should be able to distinguish between the net area and area. If we want area, we have to throw in the negative for anything below the x-axis, so that each one of them, the area or all of them, all the areas are positive, and we just add them. If it is net area, we don't put a negative at all, just evaluate it, because net area can be negative. Right, what we have here is the fundamental theorem of calculus is too fundamental. We don't even have formula for it. Actually, there's formula, but will not be given. Right. So here we have any antiderivative evaluate from a to b, meaning substitute the upper limit, subtract the lower limit. Right. So pretty much that. So we will find any antiderivative. And usually we just let c equal to 0, right? Because we can choose any antiderivative. So we choose the antiderivative where c equal to 0. Right. So once again, let's just rewrite this. X to the 1/2. Now we integrate. We have x to the 1/2, integral of that. Increase the power by 1. Divide by the same thing. There's plus c, but we let c equal to 0 because we can choose any antiderivative. Rather have a constant c, we should have the limit. That where we evaluate from 0 and then to 9. Subtract the result. Right, 5. Divide by 3/2 is multiply reciprocal. Go from 0 to 9. Now we're just going to put 9 in, put 0 and subtract them. That gives us 10 over 3, by the way. Now put 9. And then 0. Right. What is 10 over 3? Times 9 to the 3/2 is 90. So it's 90 minus 0, because we can check the answer. Right, so should be 90. Yeah, the calculator have some calculation error, but yeah, should be 90. Right, so we can just find any antiderivative. In this case, integral cosine is positive sign. Go from pi over 2 to 3 pi over 2. Right, just put in the limit, the top, subtract the limit at the bottom. Right, sine of 3 pi over 2. 3 pi over 2 is there, and the sine is the y value, so that's -1. Sine pi over 2 is 1, so that's minus 22. Right. Now if we use the calculator, make sure it is in the radian mode. And in this case, we may not have the exact answer. Okay, if I enter the function correctly, sorry, yep, -22. Actually, it gives you the exact answer. This is good. Right, cosecant square So if we have to guess cosecant square, so antiderivative, so what derivative is equal to cosecant square? And you said, oh, cotangent. Yes, so it will be cotangent. Right, again, those are the integral. Cosecant square is negative cotangent. Right. So, integral cosecant square is negative cotangent. And there's a 5 in front of it. Go from pi over 4 to 3 pi over 4. So negative 5 cotangent of x pi over 4, 3 pi over 4. Substitute 3 pi over 4. And then subtract. Just be careful with the negative. So that's why I put the bracket here. Put in 3/4 and then pi over 4. See, there's a negative. Cotangent pi over 4. Cotangent is 1 over tangent. So what is 1 divided by tangent of 3 pi over 4? What's negative 1? And cotangent of pi over 4, which is 1 divided by tangent of pi over 4, which is 1. So we have 5 plus 5 is 10. Right. Be careful when if we use the calculator for this one. Go from pi over 4 to 3 pi over 4. And then cosecant is 1 over sine. Square. And it's a 5 cosecant, right? This 10. So that is the fundamental theorem of calculus. Now we have the other fundamental theorem of calculus. So I will write the rule here. So this involves the very distinctive derivative of the integral, and whatever the limit is will be the same as the derivative, but will be different than the integrand and the dt, dx, or whatever that, the differentials. Right, so we have derivative. So with respect to x, the limit is from g of x to h of x. The function is in terms of t dt. Right, so what's that? So in this case we don't have to integrate. We just substitute in the upper limit. But the chain rule says we have to multiply by the derivative of it, and then subtract. Substitute in the lower limit. but we have to multiply by the derivative of it. So this is the other fundamental theorem of calculus. Right, so simple enough. Substitute in the limit 16 square root of x to the 9, substitute for t, and then derivative, and then subtract, substitute in the lower limit, and then derivative of that. Right, derivative of 1 is derivative of constant is 0, so 0 times everything, so this one is 0. Derivative of constant is equal to 0, so that's why this go to 0. Because of that. Right, so that's simple. Integral of x to the square root of x, so we're just going to write that here, integral of that, so x to the 1/2, derivative 1/2, x to negative 1/2. So we have 16 x, I just say x to the 1/2 to the 9, and then derivative of this is 1/2 x to the negative 1/2. Right, and simplify 16 power to another power. I will multiply those two. 1/2 times 9, 9/2 times 1/2 times x to the negative 1/2. 16 times 1/2 is 8. And when we multiply, we add the exponent. 9/2 minus 1/2. 9/2 plus negative 1/2 is 8/2. So 8x to the 4th. Remember, there's no constant c. Right. So substitute the limit and multiply by derivative of the limit. The top minus the bottom. Right. This one. Substitute in the limit for t. I'm just going to say it. So that, and then derivative of it. Subtract. Now the lower limit. Right. Upper limit is 0. Lower limit is x to the 6. Right. Once again, derivative of constant is 0. So this is equal to negative cosine square root of x to the 6 and times x to the 6. So we have negative x to the 6 cosine of x to the 6. Right. Yeah. Of course, that is the answer, acceptable answer. But remember, way back we have the properties that says square root of a squared is equal to absolute values of a. And so we don't know if x is positive or negative. So can we say it? X squared, x cubed squared. So that gives us negative x to the 6 cosine of x cubed. By the way, x could be positive, x could be negative. So x cubed could be positive, x cubed could be negative. The nice thing about this is cosine is an even function, so it doesn't matter. Only because of cosine though. So when we have plus or minus x cubed, it doesn't matter. It's just cosine of x cubed. Because cosine is an even function. Except I forgot one thing, right? Oh, the derivative. 5x, that's 6x to the fifth. That is the derivative. Sorry. Six x to the fifth, which is derivative of x to the sixth. Right, sorry about that. So that is the other part, the other fundamental theorem of calculus. Right, next we'll get back to indefinite integral. On this problem, we have to use substitution because derivative, there's no product rule, no quotient rule, so I have to use substitution. So what I do is substitute. So let u be x to the 6 plus 4. Right, so we have x to the 6 plus 4 here is u. Now we just need to solve for the x. Right, to get to the x, we just take derivative. 6x to the fifth multiply the x on the other side. And then divide 6x to the fifth. That gives us dx. Right, now let's continue the problem. Integral. We have x to the fifth and square root. X to the 6 plus 4 is going to be u. And dx is du divided by 6x to the fifth. Right. X to the fifth cancel out. The 6 at the bottom will stay at the bottom, but on the outside we just have square root of u du left. Square root of u is u to the 1/2. So increase the power by 1. Divide by the same thing. We don't have the limit, so let's see. Right. So yeah, no limit. So this is indefinite integral. So the answer is all the antiderivatives. So all of the antiderivatives. So that's why we need the plus c. Right, divide by 3/2. 3/2 at the bottom. Multiply reciprocal. Right, 2 and 6 cancel out. That gives us 1/9. U to the 3/2 plus c, and u is x to the 6 plus 4 to the 3/2 plus c. Right. Right. Next, on this one, I will rewrite this, put the dx on the back. We're better that way. Right. Now substitution. The usual suspect. inside the parentheses 7x squared plus 3. And then so we have the substitution. Now just need to solve for the x. Just take the derivative 14x, move the dx over, and divide by 14x. Right, now we have all the recipe for the substitution. Still x on the top, the bottom though to the fifth. We have u, and dx is du by 14x. Cancel out the x. And there's a 14, right? At the bottom. So move outside, still the bottom. Just need one on the top so the whole place. So we have du and then u to the fifth at the bottom. Also need one on the top. Right. Just rewrite that as u to the negative 5. So we can use the power rule. Increase the power by 1, divide by the same thing. Let's see. Right. Divide by negative 4. Of negative 4 over 1. Right? We can write this as a fraction and divide by fraction, so we flip it. That's what we have. Right. 1 over negative 56 u to negative 4 plus c, and finally substitute in for u 7x squared plus 3. Don't forget the negative 4. So because the problem originally have x in it, the answer must have x in it, so we need to substitute back in for u.